Okay, so let's have a little deeper look at cloud computing, and especially in using the Amazon Web Services. Okay, so generally what we have with cloud computing is an on-demand self-service where we can actually get extra CPU, memory, bandwidth, storage resources whenever we require them. This leads us to some rapid elasticity where customers can scale up and scale down whenever they require. So for example, if we need 1,000 new web servers at any given time, then we can create them for an hour or so, and then we can actually remove them from our infrastructure. We also get location independent resource pooling, where many customers can actually share the same resources without actually knowing where those resources actually exist. And we also get this pay per use, where we either pay for our time, CPU, storage space and so on through advertising or through actual usage. So that gives us a concept of a private cloud, which is owned and run by an organization. We can get a community cloud, where we can get several organizations with some sort of common purpose get together and create their own cloud. We can have a public cloud, such as those provided by FlexiScale, Amazon Web Services, Rackspace and GoGrid and so on, where they actually sell cloud space and the cloud infrastructure. And we can also get a hybrid cloud, which has 2 or more clouds in it. So just to recap the main levels that we can have infrastructure as a service, and in that way we can actually see our virtual images, we can set up firewalls, we can set up rights and so on, and we can even load balance between our servers. We can also apply IP addresses in an elastic way to our servers, the instances that we create, and we can also revoke them. So Amazon's web services are the best example of infrastructure as a service, and we normally have a pay per usage point of view. With this we can have APIs which interface from our own applications and create these instances, or we can use command line tools to be able to manage them. We then get up to platform as a service, and at this level we don't actually see the servers, but we see services. So a good example of this is Microsoft Azure, Amazon ec2 and the Google application engine. So we might have a security service, data storage service, user instance service and so on. And at this level we tend to see things like SOAP and WSDL to be able to discover services. And then above that we can have software as a service, and this is where the user can actually directly change the software for their own given purposes. So we see Twitter, Office packages, email and so on are good examples of software as a service. So let's have a look at the Amazon Elastic Cloud, or EC2. So this at a core is the Elastic engine, or the EC2 cloud. It uses the Zen hypervisor for its virtualization and includes 2 main data centers in the US and 1 in Ireland. We also get the simple storage service, Amazon S3, where we can actually store files inside the cloud. Along with this we can get Amazon CloudFront, where we can actually place our content provision or our web services as near to the actual consumer of our content as possible. So our applications get placed at the edge of the Amazon cloud, so they are near to where they are actually consumed. We can get a simple DB service where it mimics a traditional database, so it's a structured data storage. We'll find that Amazon Simple Storage uses buckets in a simple way. If we want the reliability of databases, then we use the Amazon Simple DB service. And then if we have grid computing applications, or we have places where we can have multiple subscribers to messages, we can have some sort of service queue that we can post messages to, and then subscribers can read them as they require. The infrastructure uses what are called RESTful web services, and these use the HTTP protocol as it was meant to have been used in the first place. So we're moving away from the normal type URL where we pass parameters towards defining the actual resource within the URI. This gives us a much more structured approach to our service provision. And RESTful is a stateless method to be able to pass HTTP requests to a web service, and then for it to be able to create new resources, to be able to read them, update them, and delete them. So in this way, we don't need a stateful where we need to keep sending in HTTP requests and the service remembers these requests. RESTful services allows us to go for a non-stateful approach, and this uses get, post, put, and delete to be able to create, read, update, and delete, which is the basis of CRUD. So many cloud and service-orientated systems use RESTful web services, including Yahoo, Facebook, Amazon, Azure, and so on. And it's a lightweight alternative to the more complex SOAP and WASDL service infrastructure. So let's have a look at the S3 service, not the E3 service. With this, we define a number of buckets, and these buckets are where we store our objects to, or normally these would be files. So with this, we create a unique namespace across the Amazon cloud. So as long as it's unique at that given time, then we can actually create them. So in the case of S3 commands that we can install, MB creates a bucket, put will put a file or an object into our bucket, get will get it back, ls lists our buckets, ls in this case lists a specific bucket, we can delete it, a file, and we can also get rid of our buckets too. So we pay on a pay per usage basis, and it's equivalent to 15 cents per gigabytes per month. Okay, so let's have a look at an example. So we're going to run a Linux image here because it's actually easier to run it. So the first thing to notice here is that we've actually set it up so that we can use the S3 commands. So let's have a look at a basic command such as ls. And the reason that we can actually use this service is that we have actually set up the access permissions. So let's remove that one. Okay, so what we have is two pieces of authentication here. We have a private key, private.pem, and we have a certificate. So the PEM contains our private key to access the service, and cert allows us to provide our identity. So we've actually set up the access to this. So let me find it. Within our bash shell startup, and we should be able to find our command, hopefully. Okay, so the first few lines here, we define our private key and we define our set key. So whenever we're using the commands for the ec2 cloud infrastructure, it uses those to authenticate us. Okay, so here are, let's have a look, and here are our buckets. So let's create a new bucket and put a file into it. So we use MB, and we'll create S3 build new bucket. Okay, so it's created our bucket. And now what we can do is that we can copy a file over. So we'll use put, and we'll put one.txt over into the bucket. Okay, so we've not done that correct because we need to give the name of the object on the other side. Okay, so that's fine, that's worked. And now what we'll do is we'll list our bucket. Should have given it a shorter name, but never mind. And there we go, and we can get, we just erase one.txt. And we'll get it back again, hopefully. Hopefully we've not lost it. So just do a get. And we'll get it back from our bucket. This might be a short-term storage for us. So we've got it back, and then we can obviously delete it from our bucket. Oops. Okay, so that's our file gone. Just make sure it's empty. And then we don't want our bucket anymore. So hopefully now our bucket is gone. Okay, so we can use the S3 commands to manage these our S3 storage. We can also use our application programs. Okay, so let's have a look at an example using Visual Studio. Just find that example first. Just close this solution. And this uses some standard code. Okay, so in this case, what we've got is we've got our wrapper, and from this wrapper we can delete a bucket, we can create a bucket if we want, we can list a bucket, we can get payments on it, we can encrypt and decrypt our files and so on. So through this wrapper we can interface to ec3. So in this case we have a method called listBucket. So we take a wrapper and this will list all our buckets. We will then create a bucket using addBucket, and then we'll just list it again. So we can do a whole lot of other things like stream decrypting and querying and deleting objects and so on, but we'll just do a very simple one just to prove the principle that we can interface through an API. Okay, so this should list the bucket, so we see an XML string comes back, so from this we should be able to see our buckets. So here they are there's the names of our buckets. So we'll create a new one. Okay, so we'll call it that. Hopefully that doesn't exist anymore, anywhere. So we can see here that we now have my bill bucket has been created. And then it's been deleted. Okay, so in this way we can interface to our S3 services through an API. Okay, so that shows some of the commands: ls, mb, put, get, del, rb, and so on. So let's have a look at the Amazon EC2 Elastic Cloud. And what we have is that we have what's called an Amazon machine image, or an AMI, and it's from this AMI that we actually create instances. So we could create one, or we could create 1,000 instances of this virtual image. So in this case we've created 2 new images, each with its own instances, each with its own unique ID. So we can then manage these either with the command line tools or our API. It is also possible to capture our own operating system, our own image, such as a VMware image, or from our own desktop into a VMware image, and then we convert into RAW format and then upload that into an AMI, and then we can instantiate our own instances. Okay, so the web interface looks something like this. So we'll have a look at a real example. So let's have a look there. Okay, so if we have a look at our dashboard, so we can see here that we're using the Eastern Coast data center. We can create an instance here from an AMI. So if we have a look, we should be able to see that there are a number of AMIs that we can use. So this just shows the Amazon images, but there's approximately 4,500 publicly available images that have been loaded. So we can see here this is a Windows with SQL Server standard. There's an IBM one, Fedora, and so on. So we can create instances of any of these AMIs if we want. So there's a Windows 2008 with SQL Express and so on. Okay, so from here we can create an instance, and we can have a look at the instances that are running. So in this case we've got 3 instances that have been created. 2 are stopped and 1 is actually running just now. So we can start up any image that we want at any given time. So we can do that from the command line or our API, but we'll do it from the console here. So it takes approximately 10 seconds or so to start the image up and for it to be running, and then it'll keep running until we actually stop it or we can terminate it. If we terminate it, then the image will be automatically, our instance will be deleted for all time, and we won't have to pay for it anymore. So the pay model is that we get charged per hour for every hour that these instances are alive. Once we stop them, then we don't actually get charged for them. Okay, so if we have a look to see some of the parameters inside our image, so we'll have a look at this one. So we can see here some of the details about that image. So this is the address that we can access it by, and so this will change every time we restart the image. If we want to allocate it to a certain domain name or an IP address, then we've got to purchase an Elastic IP address. So the key details here is that we're using a security group called Bill in this case. So we'll have a look at that, and that should tell us, as we're using infrastructure as a service, it will tell us what our basic rights are to be able to access the image. So what we'll do is we'll enable remote desktop, RTP, and then we should be able to communicate with our instance. Okay, so we're using this one here, and then what we'll do is we'll just find out what the domain name is. Do that, and then we'll just try and connect to it. And we need to get the password right, obviously. takes a little minute to connect. There we go. Okay, so this is a Windows 2008 image, and we can see that we can just use it just like a normal computer, but that it's obviously a virtual image. And what I've done here is I've actually created a web server which runs. So we can see here port 80 is actually open, and we'll just check that it is running by checking it on a local basis. HTTP. Just takes a little minute to start up. And there we go, there's our little simple default page, and just to prove that that is the case, we just go to our inetpub.root, and there's our little page there. So what we should find is that we shouldn't be able to access our page, our server from outside, because hopefully we've actually firewalled it so that it's not communicatable over the internet. So let's actually try and contact it. Hopefully, because we're using the infrastructure as a service, we shouldn't be able to contact it. Okay, so although we are running a web server, there is no way to contact it. Now what we'll do is that we'll go and see if we can add HTTP access to it. So we've got remote desktop access. All we need now is to see if we can get HTTP. So now what we can do is define that we will open up the firewall. We can obviously define a range of addresses that we want within here, but we'll open up the web server to all external addresses. Okay, so let's go back, and hopefully if this is going to work, there we go. Okay, so what we've done here is that we've created a virtual image, we got remote desktop to be able to connect to it, and then we opened up HTTP to make it accessible. Okay, so we can do the same because we're using infrastructure as a service. We can add any protocol that we want. We can define the TCP ports that are available. So we can go and open up certain ports within a certain range. So if we wanted to enable between port 21 and 25, we can obviously set it up such as this. But this is the real strength of Amazon Web Services, in that we can create our virtual images, and then we can define the basic infrastructure for them. Okay, so let's go back to our instances here. So we have an instance number, the AMI it's based on, what the file storage is. In this case it's a small Windows image. And we can define a lifecycle, our publicly available DNS, and so on. Okay, so that gives us an overview. Okay, so there's our virtual image in here, and we can obviously move around and look at all our logs and things like that. Okay, so there only seems to be a few logs in there that have been created. Okay, so the key principle here is that we can actually define our firewall rules and then get access to our web server. So what we'll do now is that we'll have a look at the tools. That we can use for ec2. So this is the command that's used to install the tools into a Linux image. So let's have a look at the range of commands that we have. Just to save time, that will actually just Okay, so here are all the commands, ec2 commands. So we can do things like describe the image, instances. We can look at all our instances that we have. We can describe our images, which will show us all our AMIs that we have. We can assign IP addresses, we can open up ports, and so on. Okay, so let's have a look at just a simple command. Okay, so that just shows us our version number. So the key thing that we have is that we have two methods of authentication. We have assert.pem, which is our authentication certificate, and we also have our private key. So these are stored in two files, and then we can then add them as part of the login, as part of our bash shell. Okay, so we can see here that as part of our bash shell, we define where the private key is and where the certificate is. So when we access the ec2 cloud from the command line, then it uses those two files to authenticate us. Okay, so let's have a look at another command. So let's have a look at our images. So we'll have a look at just the images provided by Amazon. Okay, so that's the owner. We can do -o self to be able to look at all our own AMIs, and we don't actually have any created just now. So here are all the AMIs that we could pick from that Amazon have created. There's some Fedora ones and some demos and so on. But we can look at the whole lot of all the publicly available images that we want. So now let's have a look at the instances that we have for our account. And this should relate back to what we've seen in the web browser. Okay, so there is the images, and we can see here this was the one that we're running earlier on that we contacted to, and we can see that it is running where other ones are actually stopped. Okay, so let's have a look to see if we can create our own new instance. Okay, so we're going to create a new instance based on one that we've already got. So this looks like it's a Windows 2008 image. Okay, so we'll just start that up. So this is us now taking the AMI, creating an instance. So it will take 10 seconds or so to actually start the instance up. So it's just pending just now. So we'll have a look to see if we can actually see it with inside our web console yet. So there's 3 images just going just now, and we should see our 4th one come in. We can use the -n option to create more than one image. If we wanted to create 5 images, then we would use -n5. So we can see here, here's a new image, and it's running quite happily now. So it's using the default security. So default security will tell us which ports are open. So it looks as if pretty much all the ports are open there, so we should be able to connect to it, and also we should be able to remote desktop to it. Okay, and hopefully we can go back and actually see our instances again to make sure that it's actually running. And we can see it in there. It's a bit difficult to see from the command line, but it will actually be in there somewhere. And here we are here. Oh no, I think it's this one actually. Okay, so we can remove our instance, so we can terminate it just to get rid of it. If we don't want it, we can stop it if we want. And let's terminate this instance here, which I think is the new one that we've just created. And it should be gone in a few seconds, hopefully. So it's just shutting down just now. So we'll have a look to see if it's still there. So we'll stay in this browser window for about an hour. Once it's now terminated, so we will stop paying for it within the hour. So we'll see it here inside our console, our web window, but after an hour or so it will have actually gone, so it doesn't clutter up our basic interface here. It just takes a little minute to terminate it. Obviously to terminate it, it's actually been deleted and not just been stopped. Okay, so it's just still terminating just now. Okay, so there are a whole lot of commands that we can actually use. We can also define the ports which are open using the -p option with inside it and the ec2 tools. Okay, so let's see how we're doing. And hopefully it should. Obviously, to stop it takes a shorter amount of time than it does to actually terminate it. Okay, so let's have a look at an API example. So we've got some code here. Two things you provide is your Amazon access key and your secret key. So it's not shown in this example, but it's actually set. So in this case, we've just provided a Windows form it's using standard code. And we can see here, we can actually look at the images that we've actually got running. So we can see here, there's the instance just shutting down just now. And we can connect from here. So now let's from the API, let's actually create a new instance. So we'll start it up. Just takes a little minute to start. So hopefully we can see that from our console. There we go. Okay, so it's already running and it's away going already. And we've done that through our API. If we just refresh there, then we can actually see our instance running. Okay, so in this way we can actually easily create applications which can create virtual images, create our web services, and then we can actually consume them. Okay, so this is given a practical example to the Amazon Web Services.